Okay.
Okay. And then, hello, everyone. My name is Devira Gabriel. Welcome to the HOT Ecosystem Community Meeting, our first one. I will be moderating our meeting today. I'm a senior research terminologist at Johns Hopkins Institute for Clinical and Translational Research. We are recording this meeting, so I want to provide the standard disclosures. If you object to being recording, then we invite you to leave at this time, and we will have this recording available for you to look at this in your asynchronous viewing pleasure. Well, we are going to, we have some limited technical abilities today, and so we have some time scheduled at the end of the meeting for discussion and questions. So if you could, you can go ahead and put things in chat, and we can get to those, to your discussion comments later. And without any further ado, what I'd like to do is introduce our first speaker, who is Dr. Melissa Handel, who's the director of Oregon Health and Sciences University Translational and Integrative Sciences Lab, and also the program director here at CD2H.
Thanks very much, Devira. Boy, we are starting right on time. Let's see if we've got who we've got on here. Welcome, everybody. Thank you so much for attending. We've been working in a project called the HOT Ecosystem for a little while now, and we this initiative really came about a year and a half ago, when a number of the different terminology groups got together and said, how do we work better together? How do we create more of an ecosystem of terminology development and use and equivalencies and standardization across the different terminologies? And how do we do that in an open way? And we really, you know, if you really think about the level of duplication and lack of interoperability across our different clinical terminologies, there's a lot of mapping and there's a lot of different integration approaches, but there's really not a systematic way of sort of thinking about the long-term future of our clinical terminologies and how could we sort of, you know, kind of coalesce them into a more collective development vision. And so the overarching goals of HOT are quite large, and what we wanted to present to you today what the community has been working on so far. There's obviously a lot to do and a lot of players in the world to realize that vision, but there's a lot of foundational technical work that needs to be done to simply assess requirements and feasibility and start to garner some traction on that. So I just wanted to quickly introduce this notion of a data ecosystem. This is a figure that was produced for the Joe Biden Cancer Moonshot data sharing report. And obviously you can't read all the little bits, but the goal of representing this is to say that there are very many dependencies in our, you know, clinical and translational research environment where the tools and databases and clinical care practices and patient-centered services all depend upon a foundation of interoperability. And a HOT ecosystem of terminological services is foundational for that interoperability. Next slide. So just to remind folks that the central dogma of biology is that, you know, our genetic makeup, our endowment, plus our environment over time leads to physical phenotypic features or traits. And the standards for representing these relationships for all of basic research, translational science, and clinical care must be up for encoding not only the representation of these things, but also the relationships between them. Next slide. So these are just some of the examples of the types of, you know, properties that we see in our terminological resources, that not every relationship between a gene and a disease is one of causality. There are many kinds of relationships that must be captured in a systematic way. Next slide. So of course, semantics are the ultimate universal converter, and that's why we're all here today, is to try to figure out how do we actually create systems that work in all those different diverse contexts that we might want to have interoperability. Next slide. So the goal of the health open terminology ecosystem is really that terminology is a commodity, is a resource that we can all use and contribute to and evaluate and evolve. And so the goal is to provide access to health-related terminological resources, so ontologies, classification systems, thesauri, lexicons, value sets, vocabularies that meet the FAIR criteria. And we'll talk a little bit more about that in Shahem's portion of the talk. So we have to have quality and sustainable and dependable terminology services and development to ensure that we meet these goals. Next slide. So this is just an example. From our group, there are many examples. They're all built and designed still quite differently. But in this context, we have the human phenotype ontology used for describing phenotypic features, especially in genetic disease diagnostic contexts. And there's logical interoperability in the underlying logic and how the terms are defined. So for example, over on the left, hyposmia is defined in terms of a gene ontology term for sensory perception of smell being abnormal in a patient that would have that phenotype. And this logical interoperability supports data integration and many different kinds of analytics because of its relationship to a very large data set generated by the GO consortium. Here, over 34,000 annotations in 22 species relating to that gene function. So terminologies then really are key for interoperability across clinical data models as well. So we all work in a world where there are different flavors of clinical data models, and many institutions support more than one. So some of the pain points that come about in that context are the significant effort that's required to transform from one data model to another, specifically in value set mapping and semantic alignment of the context for the use of terminologies in those contexts, an inability to share or discover the transformation methods and how they're handling the terminologies in those contexts, a lack of versioning, provenance, canonical or persistent identifiers, and licensing for that content. So, even though we may have a quality, transformation method, we may not understand enough about its provenance or its licensing to actually reuse it. The solutions, one more back. Solutions involve making these things shareable and discoverable, creating standardized tools. We'll talk a little bit more about the work we're doing on a CTS Lite terminology services. And honestly, just having a compendium of a directory of the different types of resources that are used so that we can start to use and evolve the ones we have rather than constantly reinventing the wheel. Okay, next slide. So finally, the basic needs that the HOT project serves are making data more discoverable, helping build cohorts, deriving more information from the data for analytical purposes, getting data out of the EHR in a systematic and reproducible manner, interoperably being able to combine data from different sources, and also assuring data quality. Next slide. So this is our last slide until we'll hand it off to Shahem. So we're developing an open terminology portal. It will contain community development and coordination features, a software and services registry, as I mentioned, a catalog of different terminological initiatives, development resources for contributing content, information about how to host resources in an interoperable and public manner, educational materials and tutorials, both from us as well as the community, as well as a suite of mapping services and resources relating to the terminological services that we're working on. You'll hear more about that. And then also, we've been in conversations, thanks to Devira's help with the BioStars organization. We'll be hosting, in collaboration with BioStars, a community group in that context that's really intended to be a global conversation around terminological resources. Okay, I'll hand it off to Shahem.
So our next speaker is Dr. Shahem Saeed. He's the Research Assistant Professor and Semantic Engineer at the Translational and Integrative Sciences Lab of the Oregon Health and Sciences University. Welcome.
Thank you, Devira, and welcome everyone to our first presentation. I'm going to briefly cover a couple of efforts that are still a work in progress. So as Melissa mentioned, the goal of HOT is primarily to develop a collaborative community that contributes and reuses available resources. And to try to understand the scope of the HOT project, we thought we should think about and list the various requirements, use cases, and so forth that are within scope. And I tried to organize them here according to the FAIR categories, but they really don't have clear-cut boundaries. I'm going to mostly just read through this quickly. So there are licensing and copyright issues that affect findability and accessibility, standards for publication and where they are deposited, registration, provenance, authenticated access when needed, portals for UI guided search, term requests, community interaction, and so forth are important. It would be nice to have a central portal, even if it's simply guides to other portals. We also need API services for retrieval, validation, automated term requests, and other related terminology services. For interoperability, it's important to have versioning, so people that use a resource to different projects, if they want to be interoperable, they need to be clear about the versions. If they're using different resources, mappings become very relevant, and mappings also have to be versioned. Identity and identifiers is a critical issue, and there's a need for a canonical identifier versus locally minted ones. There's also a need to have an understanding of upper ontology, semantic issues, the various relationships are used in the various systems, additional metadata like labels, synonyms, definitions, and so forth, authors, and so forth. There are a lot of resources out there already, so reusable, making reuse of existing resources is really important. And for a resource to be reusable, it really needs to be constantly developed, where new content could be added when the next use of the resource is necessary. There's a lot of work that gets done within a project that's kind of specific to the project, so capturing and publishing value sets that are created within a project, mappings, and so forth would be very useful for the community in general, and we should try to kind of provide tools for that. Documentation and wiki-like environments to collect and curate terminology-related knowledge and references and links to other resources, I think is very helpful for reusing what's available. Developing reusable components like web applications or other kind of tooling needs would be also helpful. Cataloging what's available is also necessary. And the next slide will show our attempt to try to kind of catalog the requirements and what's available. So here there's a link to a spreadsheet, and there's a screenshot of it, and we'll take a quick look at it at the actual sheet now. Vera, if you could jump there, I'll talk through it while we're looking at the sheet. So here, there's a first tab. It's a README that kind of briefly describes what's in the sheet. The second tab is a matrix. And the first three columns, A through C, is our attempt to list the various requirements that I kind of listed in the previous slides. And they're sort of organized here by their higher level category. They don't necessarily match what was on the previous slide, but the idea is to capture the meaning there. And from column D and across, if you look at the first row, we started to list the various resources that are out there, whether they are content, service, portals, and so forth. You see abbreviations up there, but if you click on the linkable title, it will take you to the site. And the other tab that is labeled resource descriptions, this has a little bit of a description about those entries in row 3. This is still a work in progress, so this is just an initial draft. We attempted to populate the various cells for each resource based on what our small group already knows about them. But we could really use a lot of help here in trying to complete this. The goal is to have an initial draft with enough content so we could then think about how to publish this in a more readable format. And a wiki or a FAQ might be the next format for this, for the spreadsheet. So please go to that spreadsheet, ask any questions, contribute, comment, and so forth. And Devira, I think, is going to be the main contact for knowing how to work with the sheet. I think that's it, Devira.
Okay. Thank you, Shaham.
Sure.
Our next presenter is Harold Solbrig, who is the Assistant Professor of Medicine at the School of Medicine for the Johns Hopkins University. And he's going to be speaking about canonical URIs and identifiers.
Okay, just to reiterate some of what Melissa was talking about previously, the key on data transformation is that it's all about semantics. What we're really dealing with is, interesting new sentence structure, but we're exchanging paragraphs, sentences, and words in these novel new structures. And we're trying to translate between communities and between grammars and various things. The core of this whole matter is that we have to understand the intended meaning of a sentence in Model A. And to do the transformation, well, we have to first take whatever Model A is in the structural normalization, add in tacit information, add in contextual information. And at that point, we can convert this into a model that goes under the rubric resource description framework. And from a collection of sentences, we can extract those that make sense in Model B, remodel the structure, and finally express it in terms of Model B. And the resource description framework it's got a fascinating background, and it's been scary for folks because largely of the URIs, which we'll talk about in a bit. But the idea is it's a reductionist framework that it's a minimal amount of grammar that arguably is close to the minimal possible grammar, a reductionist text, and it only has, I put in 2.5 data types. There's a data type called literal, which is text, although it can be typed, so you can have dates and strings and various things. Blank nodes, which we won't talk about, but the other bit is the URI. Next sentence, or next slide. URI, a uniform resource identifier. If we're going to be talking about stuff, we need to get around to naming. First thing Plato et al. Did in Cratylus. It's going to be the semantic anchor for everything. A URI needs to name individuals, Harold Solbrig, the tree outside Harold Solbrig's house. It needs to name categories, human beings, trees, automobiles, and it needs to be able to name property and predicates so that we can express relationships between things, is-a or drives. And the key, if we're going to be talking about it and mapping this, is that we have to share these names for all of these things. Now, URI is a specification that, like all universal uniform identifiers, is intended to absorb all sorts of things. So you can reference digital object identifiers in URIs, DCE UUIDs. Those are the great little, 128-bit identifiers that you can generate on Microsoft machines. ISO object identifiers, which are the IDs that were used in the HL7 version 2. But most importantly, is you can also represent just HTTP URIs, which also are known in some circles as URLs, Universal Resource Locators. You should be very familiar with them. You put in a URI or a URL to get to this meeting today, assuming you link to it on a web page. Our goal is that each URI that we use references exactly one thing. We will be failing if we use the same URI to reference both Harold and the tree outside the house. The second goal, and it's one that people are still working on, and we need to be able to figure out which URI we're going to use to identify human being, which URI we're going to use to identify tree. We need to determine whether this is the correct one. You can find a dozen or 2 dozen URIs for human beings and trees out there. And even if you get one that's the right definition, you can still get multiple identifiers. And but because of that, you need to not only determine which the right one is, but you need to determine what other URIs people have used. Next slide. URIs, one of the reasons that this RDF thing has taken a long time to take is because of the presence of URIs in there. They're long strings of text. When you're typing them into a web browser, they help you complete them, but when you're using it to just identify things, a minor typo in there makes it an entirely different identifier. So these are a couple of HTTP URIs that are almost universally used in our communities. The first one for how we say something is an instance of something else. Harold Sobrig is a human being. And another one there, just for example, this is from the Standard Knowledge Organization System, SCOS, which this is a URI for something in a given context or language. So one thing that's been done since the beginning to deal with these things is that there's various ways of assigning shortening. So the text SKOS represents the majority of that big block up front, or RDF. And you can put them together. So RDF type gives you that full URI above, stands in place, and SKOS pref label. It's tempting to just say, why don't we use the prefixes we have there? Why do we need that big long HTTP thing? Well, aside from the fact that we do need to actually find out what do those things mean. If you put those into web browsers right now, you will get useful information out of them. But the other thing is, if you're in a local enough community, you can assign useful identifiers to it. But the problem, it's that three-letter acronym, the TLA problem. As the communities grow, the notion of our all being able to agree on a unique set of TLA is a real problem. It's already designed these days to be localized acronyms. So if you pull it in one space, you get an XS for XML schema, another for XSD, a third, you might just get one that's minted, NS1. A note of danger here that I've come across is some communities are actually moving towards standardizing the Curie prefixes and assigning them to different URIs in different contexts, which is potentially worsening the problem. Next slide. So when it comes to URI and identifier management, one of the keys is being able to find out what's been assigned and to assign it if it hasn't been assigned. And part of that, it has to be distributed. The ability to assign URIs should be up to the people that are doing them once they've done a good search to make sure that this hasn't already been named, it isn't in use. It has to be distributed. We've tried various schemes where we have one overarching authority to rule them all. And we've actually had authority wars. Our authority is better than yours. You should use DOIs rather than pearls. URIs need to be dereferenceable, full stop. If you just put them into a browser, you should learn something about the URI. That's low tech. That's technology that's available to everybody everywhere today. It doesn't require a specific service. It's time that URIs are just dereferenceable. But the other key is unforgeable. Now, normally people don't forge URIs for malicious purposes, but what's really tempting is to say, I don't remember the URI for SCOS, so I'm just going to use this. Or I'm going to be the authority for URIs, so I'm going to just assign a Perls URI to it and forget the fact that the SCOS community has minted one that everybody else uses. So you need some way of knowing that the URI came from the people that defined it. And it turns out HTTP-based URIs give you all of these things. When it comes to distribution, we already have a distribution mechanism in the DNS system. You go to ICANN and various DNS registries, and you register an identifier or a URL base that belongs to you. And you can provably show it belongs to you. Oops.
Sorry.
Yeah. Dereferenceable in this in the idea that once you own it, what we want is each owner to be able to actually say, yes, this belongs to me, and if you put it into a browser, here's what I have to say about it. And we note that this is the weak spot in the web system, because despite Tim Berners-Lee's notions of identifiers being forever, if you don't pay for your DNS name, it goes back to the pot. Or if your company changes its name, folks will take SNOMED as an example. itcd.org becomes snowmed.info. So it does change. And unforgeable, next slide. So when it comes to canonical URI management, there's another word for it. I need a closing quote on that: terminology services. Terminology services are all about finding out what the appropriate URI is to use for something. Well, what should I assign if I want to say the preferred name of human being is Homo sapiens? What URI do I assign to say this is the primary author of a paper, a diagnostic code? I also need to understand how this URI relates to other things. I need a formal structure. I need a dictionary that defines it in terms of other names, other URIs. When I'm dealing with data, I need lists of URIs. I say, what are the possible meanings that are allowed in this data record? How are they recorded? And there's an important distinction between a value set, which is the meanings, let's just take as assigned by some community for male, female, and unspecified, and the fact that they're recorded in one record as 0, 1, and 99, in another record of M, F, and U, and potentially in the third record as the textual codes for the URIs or shortened URIs in the value set. And how are they related together? Next slide. So when you're doing URI and identifier management, there's a social and a technical component. Don't have time to dive into the detail here, but the fact is that we need to work with communities to get the URIs assigned, to get them bought in, to get them served on the web. We've made some progress with SNOMED, WHO, Loink, fires showing up on the page, but we've got more work to do there. And then we also need more technical work in terms of catalogs, that just figuring out which systems do I use when cataloging papers, which systems do I use when cataloging genes. It has to be distributed and federated in the sense that people need to be able to work on them locally, available in multiple formats, and also the ability to create copies. It can't be a centralized service such as BioPortal, or BioPortal is today. Next slide. So just to reiterate on the first slide here, whenever you're transforming information between communities and resources, the key to making the whole thing work, the key to the structural normalization, the mapping to the collection of common sentences, and the transform in the other thing, the core is the resource description framework, the reductionist syntax, and most importantly, URI management, which is, in a sense, another name for terminology services. And the slides following, Melissa, I didn't take them out of the deck. Do you have anything to say, or should we just skip them?
No, these were just sort of to describe sort of what happens when we don't have good URI or identifier systems.
Okay.
So I think you've already made that point. So
Okay.
you can just go ahead. Just skip through all of these. These were just, but there are some nice examples for later for those who might want to go back to that later. Okay.
Thank you. Our next speaker is Dr. Amy Wang, who's an associate professor in the Institute of Informatics, School of Medicine at the University of Alabama at Birmingham. And Amy's going to talk to us about our collaborative enhancement of the ACT ontology. Amy,
Thanks, everyone, and thanks for attending. So I'm going to talk about a specific use case, and that is finding patient cohorts from patient data. So there's a lot of challenges currently, and using I2B2 as an example, that it's made up of different terms and concepts from different code sets. Those code sets have their own limitations. A lot of them are administrative. They have only single hierarchies, and which causes browsing limitations. You can't always find what you're looking for. And when you search, do a text search, you get multiple identical search results. And currently, the way the user interface is, you can't really distinguish the differences, one asthma versus another asthma. And also, once you get a set of search results, you cannot browse those search results to either refine or expand the search. Next slide. So this is an approach that we've taken, and this illustrates how this plays out. So you have your original ICD-9 codes for gout. I'm taking gout as an example. That in ICD-9, gout is organized as a metabolic condition, and then below you see ICD-10 CM, where gout is organized more as a musculoskeletal condition. And below you see the merged act with the ICD-9 and ICD-10. ACT is an ontology that's been distributed for people to use for I2B2 searching. It contains a lot of different standards and other content. So in that merged view, you can see, sorry it's so small, but you can see that chronic gout and gout are siblings. And that comes from ICD-10 CM. And normally you would think that gout should be the overarching parent, and that chronic gout should be part of that. So on the right, you can see what we call the UAB Foundational Ontology, or UFO, which makes for a fun acronym, that I've organized the hierarchy to have it be more logical and more intuitive, and just kind of following and having the full definition, hierarchically speaking, of gout and its children. So you have gout there on the top, and then you see the very next line is chronic gout, which is under there. So if you search for gout and you start browsing, you're going to get all gout. Whereas in the current ACT ontology, if you search for gout, you won't get the chronic gout. And you can also see from farther on the right, you see that all the multiple hierarchical relationships. So you can start from a higher node and then browse down to any lower node, and that no matter where you start, you should be able to get the things that you expect. If you see in that middle panel that you have gout, and then you have chronic gout, and gout, it's hard to see, gout of knee, and then you have secondary gout. So you can browse by the chronicity or the location or the etiology or cause. And then below that, you can see how you would browse down and get the more specific kind. So it improves the browsability of different things. Now also, if you look at that middle panel that has gout, kind of the middle column, that under gout, you see there's all these ICD-9 and ICD-10 and SNOMED codes for that. Those had all been separate before, not necessarily grouped together. So we've grouped it together so that we know that all those things would be under gout. So if you search for gout, you would get those codes. Now it's a question as to whether you would want to hide those so that people don't have to worry about that and just see gout. But this is just showing the work that how it's organized. Next slide. So this is how our overarching schema of it. So you have the ACT ontology content and other standards, things that may not be in gout that are related, and you have your local UAB terms, as well as improvements that we do to improve the organization and classification of things, and also facts from our I2B2 database. So there's a patient facts, and we try to organize it in a way so that it's logical, that people can find the things that they're looking for. And we would like to distribute that to the rest of the community, and people can take that and then add their own local terms to it, and then they'll be able to reuse that and then give us feedback. Hey, you're missing this, or this isn't in the right place, or we'd like to see this other organization, and that can feed back into our development process. Next slide. So we want to maintain the concept model. Whereas things like ICD-9, ICD-10, those are for reporting. They don't necessarily follow a full concept model. Things aren't represented necessarily the way that we should think that they should be. So we want to have concept permanence, maintaining the original identifiers. These are things that the other speakers have talked about, and also resolving duplicates, which may not really be duplicates. The next slide, please. So they're not all the same, depending on where they come from. And you have your different standards, and they all have their different version of it or different duplicate. And you have local custom content. So you can see here in our consult orders that these all represent individual instances of these burn physician consults on the right, where that term was used, but we don't know if that meant something different, or it's a different location or something. So we don't merge those, but we do have it under our main term of burn physician consult. And then you have different use cases. So maybe in diagnoses, maybe when people say asthma, they mean asthma, but if you're doing some kind of lab test, that might be different depending on the machine or the method used or the reagents. And so we can't necessarily assume that those are all the same thing. So how do we resolve them? So first we try to map things together, and we think that they're related, we map them, or we merge them together. Or maybe sometimes it's better to keep them separated. And this example here on the right, the lower for gout, so you have all those things that we've kind of mapped to gout. Maybe they're not exactly the same, but kind of pragmatically for searching, we think that that's most useful. So that we call these code children, because they're not really children as in a different concept, but they're maybe different representations of the concept of gout. So do we want to hide these or show these? That maybe we want maybe the average user just cares about gout, but other researchers want their cohort that was based on a specific code. So they would want to see those codes. Next slide. This is our current workflow. So we get the data from either ACT, custom content standards, and then hopefully community input and content. And there's an ETL there, extract, transfer, transform, load, into more like relational tables in which we edit the names, edit the relationships, add additional classes and things like that, merging and splitting things. And then there's another ETL in which I loaded into an editor, a terminology editor environment. I'm currently using Epsilon DTS, but this could be any environment. And then there's another ETL from that our technical staff transform it into the I2B2 format. And we currently put it into the development environment first, and then we review it. And that's because the different data models and the representations are so different. So then we would do a review phase, and if there's still problems, then it would go back to the ETL and go through that process again. And then after a review and it's considered good enough, it would go to our production environment, and also we have plans to put it in the test network and eventually distribute it to the rest of the community. And then feedback from that would go back into further development. Next slide. So there's a lot of technical challenges. I would say that a lot of, in addition to the content and terminology, semantic challenges, there's technical challenges. There's tooling. We've looked at a lot of different tools. We're not really sure what's best, but we're using a tool now. It's working. It's mostly a manual process, which people seem to think often it has to be done if it's something that you're trying to make it user friendly, but it's prone to errors. Is it scalable? That's an issue. There's a lot of these different data models requiring all these multiple ETLs, and the ETLs cannot be automated where I could just push a button and it happens, because as I'm developing and iterating, there might be different relationships or different attributes that need to be added. So it's a very iterative development process. There's also parallel development. So as I'm developing things in my environment, things have to still keep running inside I2B2, and so they're always getting things from other places. So there's these multiple development efforts going on that have to be then resolved. Also technical resources. So with all this, there's a lot of technical resources involved, and all of our people are sort of tasked with doing all this analysis and helping people get their data sets for their research studies, that if we were able to get this I2B2 to work better as a self-service application, which is its intended use, then that would hopefully free up some of those technical resources. Also the user interface, I mentioned before that when you search or browse, it's not always intuitive. You get duplicates and you can't refine or expand things. Next slide. So I want to prioritize content. So right now we're focusing on diagnosis. The diagnosis space and things that are frequently used would be also another way to organize and prioritize things. Things that are important to value sets and data models. Things that we already have, so that things that we already have developed, let's work on that and get that better, and versus starting in a totally new area. And obviously everybody's interested in COVID-19 related content. And then community input on what's most important and what people need. Next slide. So our roadmap, definitely would want to get it more automated, which the community could help with that. And giving suggestions on what best practices that work for other people, testing and iteration based on local feedback so we can improve things. We want to load it into the test network and Shrine to get it out there. I've got that twice there. And then wide distribution of the content and updates and mapping to data models. Next slide. And how can you help? So this is a collaborative community environment. So I want to improve workflow and efficiency so we can get it better or get it to work for people. So that includes content and technical resources, both suggestions, maybe resources. There's a lot of things that are out there free and help and where we can get help. Collaborative development, and so that want everybody to help us develop this and crowdsource it. Hopefully we would get to the stage where we could do distributed development and then ongoing testing and feedback so that we can continue to improve and have it work better for everybody. With that, I think that's my last slide, and thank you everybody for your attention.
Thank you, Amy. Our next presenter is Daji Zhao, who is a senior software engineer at the Johns Hopkins Institute of Clinical and Translational Research. He's going to talk a little bit about our CTS Lite terminology services model.
Thanks, Deborah. I'm going to go a little bit more technical here. This is a terminology service that we're building as a component of the HOT ecosystem. In this slide, it shows the overall architecture of the Common Data Model Harmonization Project, or CDMH. We are just using this system as an example of a use case of the terminology service that we are building. So let me explain what the overall architecture of CDMH here is. So on the left side, the blue boxes are representing a local system where you have your local EHR at the bottom, and you might have a local other CDM models, data in other CDM models. And then you want the CDMH, the goal is basically to aggregate these data from a local system to a data repository that is in the light green on the right side, and to serve that to different agencies or systems that can easily get the data. So they don't want to, so they don't need to query these local systems individually. They can just go to the centralized data repository to fetch the data in the format that they need. So the terminology service, which is represented as the flower-shaped circle here, and the icon just represents the nature of the terminology service, that it can provide mappings between different terminologies or data models. So as you can see, the flower-shaped icon appeared several places. So at the bottom, it can be used during the data transformation between the EHR to a local warehouse, or eventually go into the file repository. Or it can be used when you map the CDM, local CDM models to Fire. But it can also be used during the data aggregation process, and also when the data exported into the formats that the agencies or the clients want to use. Okay, next slide, please. So here is, we're just gonna dive into that system and see how the mappings, the code map are built and also used. So this is the code map service, which was the flower shaped in the previous slide. So here you can see that the code mapping definitions are created basically by the mapping experts, and taking in consideration of various ontologies such as SNOMED, ICD, or HPO, and also using the value sets. Here we are just showing a couple of examples from value sets from the value set authority center, VSAC, or the FHIR term services. And then they can refer or they can use the models, existing mapping models or other data models from the CDSR from NCI and build this map definition, use the map definition process to build the concept maps or the code maps. And then the code map service on the right side will use this service. Use these maps, load them into the code map service. Next slide, please. Another way to provide these maps, the code maps are that, so on the left side, they are exactly the same as the previous slide, but on the right side, the maps can also be loaded into NCI semantic infrastructure and curated by the NCI curators. So this just shows that another way of persisting these mapping data are go through the NCI and saved into NCI semantic infrastructure such as CADSR, NCI thesaurus, or the NCI metathesaurus. Next slide, please. So on the right side, once it's loaded into NCI semantic infrastructure, then the code map service can use that and provide that through the API to the other processes in CD2H, which is on the left side in the green boxes. So one type of usage is it can be used in during the data transformation process. For example, the code maps, the data transformation services might use a map definition from the code map service that is created by the mapping experts to transform data from
Sorry.
Yeah, that's okay. To transform from one data from one model to another. Yeah, next slide, please. Or when someone build a query, just like you build a query in I2V2, they can build a query using the data from the code map service. And for example, if you are building, it can use the service to map data, map terminologies between standard code systems such as ICD-9 or Snowman or ICD-10. It can also, the service can also serve up subsets from a collection of existing code systems or value sets. So these data can be used to build the queries. Next slide, please. Okay, so this is basically the overall the system architecture of this CTS Lite terminology service. We call it CTS Lite because we're building it based on the CTS2 or Common Terminology Services 2 specification. It's tailored to meet the requirements for CDMH and the CCDH, but it can we are generalized it enough so it can meet other requirements as well. So in the middle of the slide is the system of CTS Lite, and on the left side is the data source where we get the data from and the mapping from. And on the right side are the potential clients that or potential projects that, projects that can potentially use this service. So we are building the API, the service using FHIR specifically, but we are generating the model and we are calling it TCCM, the Terminology Core Common Model. And we're using a technology called Bilink ML to build it. So in the middle, you can see the two big boxes are, we are basically using either the FHIR terminology service, or if that's not enough, we're building a different resource model. And those small boxes are the components. For example, it can search, or it can provide a batch load using a bundler, and it can load data using a loader from data sources, and it has a provenance management system, so where you can manage provenance data such as versions. It can also wrap current APIs. For example, Loink has a FHIR terminology service, so we don't want to reinvent the wheel. We'll just wrap it, but still people can go through our service to get Loink data. And underneath, we are using GraphDB as a triple store, a type of triple store. We're basically trying to convert the data into, if we need to store any data, we're trying to convert them into either RDF or using Neo4j, which is a property graph database. Neo4j provides some really nice functionalities in graph manipulation. So we are thinking that some of the projects might need to operate on the value sets, which are basically graphs, and we need to a way to do the graph operations very easily, and that's why Neo4j, because Neo4j provides really advanced algorithms in that, so we're using that as one type of storage. I think that's it. That's the more technical point of view of the system that we're putting. Thanks.
Thank you, Daji. And we're going to finish up with Dr. Chris Shute, who's a professor of medicine, public health and nursing, deputy director of informatics at the Institute for Clinical and Translational Research at Johns Hopkins University. He's also the chair of our Next Generation Data Sharing Community Core, of which HOT is a component, and a co-PI for CD2H. Thank you, Dr. Shute.
I'm sorry, I was on mute there.
It's quite all right.
Thank you, Devira. Good heavens. This is the non-technical component of the presentation. And I'm delighted to follow Daji, who sort of outlined some of the more substantial components of what's being done. This is to provide context for doing it. And I want everybody to appreciate that these are not purely academic exercises, that what is being developed in the context of this project is actually being deployed and used in many projects around the community. And we'll kind of take them in clockwise order from the top. Formed as of last Friday is what is now called the National COVID Cohort Collaborative in partnership with CTSA and other NIH agencies, where the harmonization of data from many clinical organizations contributed to a central repository on an NCAT server is clearly going to leverage many of the tools and resources, not the least of which would be mapping and value set resources, as we take information from various clinical common data models and integrate them into a singular form. Correspondingly, the Center for Cancer Data Harmonization at the CCDH, run by NCI, is taking data from various commons elements, so the genomics commons, the proteomics commons, the animal cancer commons, and the like, and harmonizing them into a common framework for cancer query across these data sets, which of course requires that we have comparability and consistency in the underlying rendering and representation. Many of you are aware that the new HL7 accelerator for translational research, the Vulcan accelerator, is now underway, and CD2H is one of the Catalyst founding members, where many of the efforts that we are describing would harmonize nicely with the existing novel resources being proposed or profiles being proposed for translational research that can accommodate and adopt elements that are found across that community. Similarly, with HL7 FHIR in general, moving to the left side, the CDC MedMorph project, on which Devira and myself serve on their steering committee, is working very closely with the user stories and use cases being developed in this community. And we've already heard from the ACT network with, well, at least the ACT project from Amy Wang, but we're also coordinating with the ACT network in terms of ontological frameworks that, again, leverage much of the underlying tooling and resources that are being described. The CDMH project, well, next slide, we'll go into that. The next slide is the CDMH project, and I think Daji showed this slide earlier. This is an effort, as you can see, with the all-star banner along the bottom of many NIH agencies, FDA, CDC, and HHS in general, to create a common framework, a software framework for data repositories derived from clinical sources based on the underlying FHIR standard that would then be queried in a distributed query framework by federal agencies such as Biosense or NCATS or other agencies that have a legitimate need to know clinical information. This would be highly pertinent in the context of the COVID crisis, but it's premature to roll out this the full elegance and generalizability of this program. Hence, it's being more or less superseded by the N3C, the National COVID Cohort Consortium or collaboration. Next slide. This is just a schematic of the cancer efforts where we're taking information from, as you see, immuno-oncology data commons, genomic, imaging, proteomic, and others, many others, to create the common meta model and structures across that will form the cancer research data commons in a harmonized context so that investigators can ask queries that are semantically understood across all of these different commons, even though, ironically, they all have somewhat divergent models. And the point is to have harmonization of these efforts so that we can create an interlingua or an intercomparability aggregated model for these kinds of queries in the cancer space. And finally, the next slide, I believe, is time for questions. We have 2 minutes. I'll defer to you, Devera, to field those.
Okay, so I'm going to need to stop sharing so I can take a look at the chat. Thank you, everybody. Reviewing the chat, could we share a link to the resource spreadsheet and slides? Yes, we'll be providing those. And that is in the chat. Melissa provided those. And then there's some other comments there in the chat. And we will have a recording of the meeting today on the CD2H website. Is there anybody in the audience that has maybe a verbal question or discussion item that they would like to queue up? We still have 3 minutes. So we have time for at least 1 or 2 questions. Well, okay, since we don't have any, and we're going to be posting our materials in public places, I'll go ahead and wrap up a couple minutes early. We want to thank everybody for coming to our first community meeting. We will be hosting these the first Wednesday at this time and on this channel at this Zoom address, the first Wednesday of the month. If you lose track of that, you can always take a look at the CD2H calendar. It's posted there about how you can get back to us in our next month. And if you have some ideas about things that you would like to discuss or maybe even present, we would be very open to that. So one more chance to make final comments for many of our presenters or participants. Okay, well, thank you very much for coming to our first call, and we look forward to chatting with you again next month.
Thanks, everybody. Let us know your thoughts on things as you poke around the materials that we're providing, and we'll put everything up on our website.
Indeed, thank you.
Okay.
Thank you. Bye.